Hello everyone, and welcome back to the Fluctus Channel. In the 1950s, Boeing developed a long-range strategic bomber with a large payload capacity and used it to obliterate enemy bases during the Cold War, Vietnam War, and in war zones like Iraq and Afghanistan. The B-52 has been used for the past 6 decades, which makes it the oldest bomber of the United States Air Force.
The first thing about the B-52 is just the historical presence that it carries with it. I think when the enemy sees the B-52 fly overhead, it strikes fear into their hearts. And that's something that we absolutely want to take advantage of.
With a 159-foot-long fuselage and a 185-foot wingspan, washing a B-52 is not easy. If the aircraft is out on the flight line, it is cleaned every 120 days. However, the in-depth cleaning is conducted during phase maintenance. During the phase wash, all the panels and compartments are removed to ensure each part of the aircraft is thoroughly cleaned. The soap used in this process is potent, hence the cleaners must wear special suits and protective gear. The main purpose of phase wash is to prevent corrosion, which can have a drastic impact on the structural integrity of the metal. Sometimes, the B-52's structure can sustain damage during flight operations or while maneuvering on the runway. In such situations, the Aircraft Structural Maintenance Squadron steps in to restore the aircraft to full operational condition.
We do the structures of the aircraft. The best way to explain it is auto body for airplanes. Skin of the aircraft, substructure like ribs and stuff when they crack. We also deal with corrosion on the jet, and we deal with spray painting the jet.
In 2023, the United States military announced a series of major modernization efforts aimed at extending the operational life of the B-52 well beyond its original expectations, potentially allowing the aircraft to remain in service for more than 100 years. Among the most significant of these upgrades is the replacement of the aging TF-33 engines with the new Rolls-Royce F-130 engines. While these modern engines are designed to deliver a similar level of thrust, they bring substantial improvements in fuel efficiency, reliability, and overall performance. Over time, this upgrade is projected to save the United States billions of dollars in operating and sustainment costs. Over the years, Rolls-Royce has supplied thousands of engines to the United States Air Force, playing a critical role in the evolution of military aviation. During World War II, the company's engines powered iconic aircraft such as the P-51 Mustang, the P-38 Lightning, and the P-40 Warhawk, delivering performance that was considered cutting-edge for that era. Building on decades of engineering experience and technological advancement, Rolls-Royce later introduced the modern F-130 engine, developed to power the B-52 Stratofortress. This new generation engine represents a significant leap forward in efficiency, reliability, and maintainability, ensuring that one of the Air Force's most iconic bombers remains operational and effective well into the future. One such upgrade was the CONNECT, which stands for Combat Network Communications Technology. CONNECT improved the B-52's ability to operate in a modern combat environment by providing enhanced communication, better situational awareness, and improved combat integration. For instance, the CONNECT system allows the B-52 to securely exchange data with friendly aircraft, ground stations, and command centers. The CONNECT supports both classified and unclassified networks, providing a unique platform for coordination and exchanging information. The system also features advanced sensors, display, and data fusion capabilities, which help the airmen prepare for what they might encounter on the mission ahead. Moreover, the CONNECT system replaces analog interference systems with digital ones to enhance the crew reaction times. The B-52 can carry both conventional and nuclear weapons, which are loaded by a specialized team of munitions airmen. The bombs are transported using bomb lifts and jammers. The B-52's weapon bay is opened manually, and the airmen align and mount munitions onto the designated loading points. Once loaded with weaponry, the B-52 is ready to take off. It takes less than 10 minutes to kickstart the engines with explosive charges and gets the B-52 in the air.
Flaps are stopped. Good for the right.
You have the aircraft commander. He sits in the left seat. He's responsible for the safe employment of that aircraft. The co-pilot is one of our more junior pilots typically, though they've got the good airmanship, but we're working on developing their mission awareness. We've got our electronic warfare officer, so they are really the defensive specialists of this airplane. In the lower section of the crew compartment, there is the radar navigator, so they are traditionally the ones tasked with weapons management. And then sitting next to them on the right is the navigator, and their kind of traditional duties center around mission timing, the route.
The B-52 was designed to carry multiple bombs at a time. While it was an effective strategy, it did not allow the aircrew to alter the weapon type mid-air. Which is why a new technology named Common Strategic Rotary Launcher, or CSRL, was introduced. Which could not only carry a range of missiles, bombs, and smart munitions, but also allowed the aircrew to quickly change the weapon type at the flick of a switch. The CSRL can be fully loaded with weaponry prior to installation. However, it requires 11 hours to fully load the CSRL. Once fully loaded, the crew puts it on a trailer attached to a vehicle. For installation, the rotary launcher is placed exactly below the bomb bay of the B-52 aircraft. The CSRL is then raised and mounted inside the bomb bay. In addition to B-52, The U.S. Air Force has several other bombers in its long-range bomber force, such as the B-1 Lancer. Also known as the Bone, the B-1 features a 75,000-pound payload capacity, which is the heaviest of any U.S. bomber. The B-1 Lancer requires regular maintenance to ensure operational readiness. Before takeoff, the airmen tow the aircraft to the flight line, where they perform routine inspections, lubrication, and servicing of various aircraft systems. As visibility is reduced during nighttime operations, an aircraft marshaller guides the aircraft using illuminated marshalling wands. Before signaling, the marshaller makes sure that the aircraft's path is clear of obstructions and ensures safe operations. When the B-1 is fully loaded with weaponry, it has to move much faster on the runway to take off successfully. This may be achieved with a full afterburner. It is an additional combustion component used on jet engines to increase the thrust, usually for supersonic flight, takeoff, and combat. The afterburning process injects additional fuel into a combustor in the jet pipe behind the turbine, which ultimately reheats the exhausting gas. Apart from the B-1 Lancer, only a few other aircraft that can travel at supersonic speeds are capable of performing a full afterburner. The B-1 features a variable sweep wing, which can move from 15 degrees to 67.5 degrees. The variable sweep wing can be modified, swept forward or swept backward, and then returned to its previous straight position during flight. The B-1 uses forward-swept wing settings for takeoff, landings, and high-altitude cruising, whereas reverse-swept wing settings are used in high subsonic and supersonic flights. Similar to B-1, the F-14 Tomcat also features variable sweep wings, which allow it to operate at both high and low speeds. This unique wing design allowed the F-14 to automatically adjust its speed range and move even during turns. Additionally, the wings could be swept forward for tight turns in close aerial combat, as well as rearwards for dash speeds. F-14 Tomcat was procured by the U.S. military to replace the canceled F-111 fleet. Developed in the 1960s, the F-111 was a supersonic fighter bomber, which also featured variable sweep wings to optimize performance at different speeds. It was a superior air-to-ground attack aircraft, but was retired in the 1990s. The last surviving F-111 is still displayed at the Shaw Air Force Base in South Carolina. While advancements in aircraft technology and design continue to evolve, like in the B-1's case, the versatility and importance of the B-52 Stratofortress remains undeniable. The ongoing upgrades of the B-52, especially the engine replacements, will make it a force to be reckoned with. Besides, the B-52's long-range capabilities and payload capacity make it a cornerstone of strategic bombing and deterrence missions. As the Air Force progresses with next-generation platforms, the B-52's proven reliability and capability ensure it will remain a vital asset for years to come. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.